Hello, everyone. I hope you can all hear me. Yes, Roya says that you can. Sorry for the delay there. I was just trying to get my webcam and my audio working, but I think we're ready to go. If this is your first ODX webinar, I'll just give you a bit of a tour of the space in Crowdcast. So we'll be flipping between us and Roy, who will share his presentation on the main screen here. And underneath, you can see a space where you can type questions. So if you have any questions for Roy or for ODX, you can put them there or in the chat on the right-hand side. And if it's something that you want asked in the middle of the presentation, I will stop Roy from his PowerPoint and ask him the question. Otherwise, we'll just wait to the end and we'll go through them then. And there's also a spot for polls here with some questions already loaded. And this time we had a little bit of fun with it, where some of them there's a right and a wrong answer. They're kind of multiple choice. So we're just interested to see what you guys would pick, and just get an idea of your knowledge in the cybersecurity space. So feel free to answer those polls at any time. And I think that's all I need to give you a tour. Let me just see if I can pull up my PowerPoint for an introduction. Can you see this, or?
You have to probably switch to screen share. There you go.
Oh, here it is.
Yep.
Okay.
There you are.
You can see everything.
Okay. Somebody wanted to know if you're recording it.
Yes, we are recording it. And after the presentation, we'll be sending out an email. If you can fill out the quick survey to let us know how we did, and we'll send you the link to the archived video after that. That looks better. I'm sure, but...
There you go.
Awesome. Okay. So, let me scroll up to the top. So, welcome. Thank you for joining us. The quick agenda for today's webinar is we're first going to give an overview of ODX in case you guys are new to who we are and what we offer. Joseph's going to do that for us in just a minute. And then we'll pass things over to Roy, who will talk about Cymon and modern tools and techniques for you guys. Then at the end, we'll do open questions for either Roy or Joseph, who's the rep for ODX.
Sorry.
It's okay. And then at the end, we'll do closing remarks. Well, I'll give more information about where to get the archived video webinar and some other cool things I want to show you guys before we leave. So again, my name is Kelsey. And I'm in charge of running these webinars, and as well as social media, and I do our newsletter. And if you ever wanted to be a speaker for one of our webinars, you can always email me, and I'll let you know what what it takes, and we can discuss how to slot you in. And I'll just turn things over to Joseph.
Great, thanks, Kelsey. I hope everyone can hear okay. So for those of you who are unfamiliar with us, ODX is Canada's open data exchange. We are a public-private partnership that was founded in May of 2015 with the goal of helping Canadian entrepreneurs create jobs, growth, and wealth through the effective commercial use of open data. And so I'm the data EIR, which means that I spend a lot of time designing training programming and supporting companies as they try to understand what kinds of open data is available, provided by the federal government, the provincial government, or municipalities. We also have a number of folks on the team who can help with everything from making connections within government to get particular data sets released to data architecture and basically figuring out some of the challenges that companies might have with respect to scaling their data architecture. Just really briefly, the interest in us in putting on this particular webinar is we wanted to get the opportunity for Roy and the eCentire team to talk a bit about some of the lessons that they've learned in terms of creating a very large data repository and making that available through open APIs, because we think that that's a common problem that a lot of companies have had that we've talked to, and so it's always nice for us to be able to reach out to a company and basically give them the chance to share some of their knowledge and stimulate some of the conversation. In this case, more around big data and application development than around open data specifically. So we're really happy to have Roy Firestein here from Cymon to speak to you about their open threat intelligence platform. Roy will talk a little bit about eCentire and what the company does, and then we'll spend most of this presentation talking about Cymon and how they ingest a bunch of different data sources to come up with a really cool way to identify and help mitigate cybersecurity. So we'll also be moderating the chat, so to the extent that folks have questions or comments in the chat, please feel free to post them. As Kelsey pointed out, there's also the questions and topics section at the bottom of your screen, which is the ideal way to ask questions. For the most part, we're going to try and let Roy go through it, but if there are questions that are kind of pressing and that make sense to address in the flow, then Kelsey will moderate them and kind of interrupt Roy and get those questions out. So with that, we want to hand it over to you. Roy, are you there?
Yes.
Oh, I think I have to invite Roy on screen. There we go. We already invited Roy?
I think so.
Oh, we already have.
Perfect. Can you guys hear me?
So Roy, you should have the mic. Are you there?
Yes. Perfect.
You hear Roy. I don't hear Roy.
I think.
All right, we're just going to mute this. You go ahead.
Yeah, let me know if you can't hear me. I can't tell. So thanks for the introduction. As previously mentioned, my name is Roy Firestein, and I work for eCentire. At eCentire, we protect our customers from cyber threats. And we do this using a defense in depth approach. So first, we monitor all network traffic for attacks and patterns of attacks. Then on the second layer, we collect and analyze.
Roy, sorry, I just wanted to interrupt you for a second. I think the people can't see your presentation.
Okay.
There we go. That's the one. Yeah.
Here we go.
It shows it like that, but when I go full screen, let's see. Can you guys see it now? Okay, so let me start where I stopped. So I mentioned on the second layer at EastEntire, we analyze logs from infrastructure and applications and Active Directory, correlate them together to get a good picture of what's going on, looking for indicators such as multiple failed logins, permission issues on Active Directory, stuff like that. All of this is very valuable, but put together with the last line, which is on the host running an agent on desktops and laptops and servers, looking for malware execution and stopping it. Combining all three layers together gives a very in-depth view into an organization and any risks going on there. So as you can imagine, at EastEntire, we collect a lot of data, and we need to analyze all of it. So in this presentation, I really want to show you how we tackle the collection, aggregation, and dissemination of threat intelligence data. And all these needs were modeled based on what our SOC needs. So today we're going to cover initially what threat intelligence in cybersecurity is, and some of the common terms. So we're going to start assuming that you don't have prior knowledge necessarily about threat intelligence, but then the presentation will pick up very quickly. So after that, we'll talk about Cymon, what it is and why was it created. Then we'll talk about how it was architected, what considerations we had to make, and what the lessons we learned building big data systems around Cymon. Following that, we'll talk about what open data sources Cymon is using. And lastly, we'll talk about tools and use cases, what you can take back to work, and what hopefully you'll find something very useful in this presentation, either from the architecture point of view or from the actual APIs and tools we'll be showing you. So as I mentioned, let's start with some basic terms. IOC is the first thing that we're going to cover. It's going to repeat a lot in the presentation. It stands for Indicator of Compromise. It's an observable, a piece of information that tells us that something bad is happening. So think of it as a signature that can either run on your intrusion detection system or on the firewall. And it has information such as IP addresses or hashes of binaries. So if anything matches that, essentially we know that someone else observed the same indicator, and it means that either malware or something malicious happened. OSINT, open source intelligence gathering, is the act of collecting intelligence data from open sources on the internet. But as you can imagine, the trouble with that is the noise to signal ratio. You will have to filter through a lot of data to get that small signal you were looking for. But when you're not in a state-sponsored intelligence agency, then sometimes OSINT is one of the best sources for you, if not the only one, unless you're willing to pay. SOC is something that I've already used. It's something that that's essentially what EastEntire sells to our customers. We operate a security operations center 24/7. Their analysts look at events and alerts coming in from customer devices and sensors we deploy, and they need to make a determination whether it's bad or if it's okay. Should they block it or should they let it go? Of course, they're assisted with computer algorithms and machine learning to come to that decision as fast as possible. But for example, banks operate their own SOCs, their own security operations centers. Exploit kits are automated tools to help the bad guys send and infect your computers with malware, any type of malware, by essentially hosting it on the internet and either using advertising, they pay for advertising that link back to their exploits, or by compromising websites. The point is that it's a point and click software. All you have to do is just install it, put it on a server, and that's it. In most cases, the bad guys actually pay for these from quote-unquote cyber weapons manufacturers that work for the bad guys. C2, command and control, is the mechanism by which the malware that's on your computer communicates back to a system that tells it what to do once it got loaded on your computer. So it could ask it to lift credentials from your system or to attack another computer out there on the internet. So now that we've got some of the basic terms out of the way, let's look at the state of the threat landscape today.
Roy, I just wanted to stop you for a second. You had a question. Sarah's asking, you said you're looking at IP addresses. Do you compare those to known IP databases that tell you which IPs are likely to transmit malicious activity?
We collect signals and reports from people that say that they observed malicious activities coming from said IP address or domain, for example. And we collect all of that together. And we'll touch more about that on what Cymon is in the next section. In order to give you an idea of why we even started with this project, I wanted to share some of the problems everyone's facing. And as you know, spam and phishing emails are a big problem. Everyone's getting them multiple times a day. And I think the biggest risk is that that's probably the #1 way organizations are getting infected these days. Because as a spammer, it's basically a numbers game. You just have to send as many emails as you can. And even if you get less than 1% response rate, people clicking on the links, it still translates to thousands of people, if not more, when you look at the total number of people connected to the internet. So that's a real problem, and we need to know how to identify phishing emails and stop them. Also on the internet, something that everyone's experiencing, especially if you're an administrator, what we call is internet noise, where computers, people, and automated processes automatically and all the time keep scanning systems out there on the internet, whether it's an organization or individuals, for open ports, open services, probing for vulnerabilities on websites. Like 50% of all the scans are for WordPress plugins that were not updated, for example. That's the #1 most popular way for attackers to access servers to launch attacks from, by attacking vulnerable WordPress sites. But it would be neat if there was a way to actually identify these sources ahead of time. If you run Outlook Web Access or a VPN network, and you look at those logs, I'm sure you'll see tons of login attempts by people trying to guess passwords for your employees. And exploit kits, as I mentioned earlier. If you run a WordPress website, people will try to compromise it and embed an exploit kit link in it, so all your visitors will get infected. And malicious advertising is also rampant. You can actually visit a legitimate site such as Forbes or The Economist, and they did have in the past these issues where they offer advertising to their users, but when they don't check what ads they actually serve, sometimes the bad guys are able to kind of slip in their own ads that essentially either serve malware instead of the ad or redirect users to malware sites once you click on the ad. So all of that kind of paints a grim picture of what's going on today. And I want to also discuss what is the need and what gave rise, why every medium-sized business needs to do threat intelligence. And the first reason is you want to identify a compromise when it happens. That's a no-brainer. Really nothing more to say there. Now, the sooner you do it, and when you start identifying these vulnerabilities, now you have to start prioritizing them. And getting some intelligence on this will help you figure out what's more important, which attack is more costly or more important to repair, and how to remediate. Now, if we want to be quick about it, we want to automate the detection and response. as much as possible. The less time we spend on detecting and responding, the less money the company loses. So the faster we are, the less the damages will be. Which essentially is the whole reason behind why you'd want to do it as fast as possible. Okay, that's all good, but why do build Cymon the way it's built? Well, we modeled it based on what our Security Operations Center usually asks when they get an alert coming on their dashboard. In almost all situations, it includes an IP address. And then they have to ask three basic questions. First of all, is it malicious? Did anyone recently report any attacks coming from this IP address? If yes, if something very recent happened, then they will block it. But then sometimes when that answer is not clear, or there were attacks, but they were a few months back, that's where the history aspect of what happened behind the IP comes in useful. You now can see that a year ago, 5 attacks were launched, and this year only 1. But that gives you an idea of a pattern. And you can tell that definitely either multiple groups or different campaigns were launched from that IP address. And then when you step back a little bit, you want to see the entire subnet. Are there any other bad actors sitting on the same subnet? Is it a network that just belongs to cyber criminals, or is it just a one-off machine that got compromised? And I'll show you very quickly soon how we answer that. But now, when we look at Cymon as a product, the vision for it is to make it into a platform as a service to help you distribute your indicators of compromise and collect them. So on the left side, we see a threat intelligence analyst looking at indicators and confirming them, and then entering them to a feed that belongs to the company on Cymon. Or above him, an automated process could automatically as well be entering these events into your feed. And then on the right side, you can have either manual employees manually accessing the web interface, querying the database, or automated systems pulling the feed locally to process or compare against files or traffic. Right? So as far as we know, Cymon is the largest tracker of its kind on the internet. It's collecting reports about malware, phishing campaigns and attacks, botnets, scanning activities, brute forcing, and a bunch of other threat types. On average, I would say it's probably even more than that, because Cymon has public feeds, but it also supports private feeds. And I'm just counting the public ones for now, and on average, we're getting 20,000 and even more unique IPs every day. And but with a little less than 200 different sources, some of them you will recognize, such as VirusTotal, PhishTank, and other virus antivirus companies are also there. Anyone that offers a free feed or website or source of information about these type of events, we will automatically add it to Cymon. So a quick stats about what's going on. So that's as of yesterday morning, Cymon had 8.6 million unique IP addresses in its database and over 57 million security events. A security event is essentially something bad was reported. For example, a phishing campaign was launched from this IP, or a phishing campaign is hosted on this domain, or malware is being served from a specific IP address. That's a security event. And you can access all of that by searching using IPs, domains, or URLs. But instead of showing screenshots, how about I'll just give you a quick demo. So this is the Cymon webpage. We're just looking at some of the recent reports that came in. So let's just click on one, for example, see what we get. So the IP address that we clicked on was, sorry, the domain we clicked on was associated with this IP address. We saw it first over a month ago, but the last time we saw it was actually today, just very recently. So we can immediately see here on this page that phishing was reported, the different sources reporting on it, where the IP might be located, and the different domains that were pointing to this IP. Now, the interesting pieces of information would be in the timeline, where we can actually see that Norton.com, the Norton antivirus company, Cymon actually, reported on phishing attacks. But a month earlier, we can see that another company, OpenFish.com, also reported on a phishing attack, but each one used a different domain. This one used help.steamcommunity.de, and this one steamcommunity.info. That's another malicious AP, for example, with just a bit more information. You can see this one was reported to host malware from a bunch of different sources, over 1,300 of them to be precise. We can also see different hashes that were recorded to be hosted on that IP, and what neighbors might exist on the same subnet that were also reported. So I think on its own, for analysts and just as a brief overview, I think you can get a nice idea of what Cymon does and how useful it can be for different functions in the organization, whether if it's for analysts or if you're suspecting a specific log line if you're an administrator, or if you're just a user that wants to verify some link in an email is not malicious. But let's look at the more interesting aspects of how it was all built. So the first thing I want to tell you is that Cymon, the new architecture, is almost real time, which means that in a few seconds after you make an API call to submit data, it would have gone through our enrichment pipeline and entered the database, which means it's event-driven. As soon as something happens, the next actions automatically trigger. It's a highly scalable system by virtue of being on the cloud and using microservices. It means that the system can run concurrently in multiple places in the world. Because it's microservices, it means it's also stateless, which means that we can deploy in different regions in the West Coast and the East Coast without having to synchronize the systems. This helps us recover from big disasters, such as if AWS goes down in one region or there's a natural disaster, the system will self-heal and divert all traffic to the healthy regions. JWT means JSON Web Tokens, and that's the new standard of handling user sessions in the age of microservices and stateless web applications. The concept is very simple. It means that instead of sending a cookie, you as the user, you're sending the full credential object, you can call it. It's basically a piece of information that has anything that the service might want to send you, such as different permissions you're allowed to and so on, and it's cryptographically signed. And the main languages are Python and JavaScript. All right, so I mentioned serverless, but let's see what it's really all about. So immediately, the first thing is just, you don't have to think about the servers. All you have to do is write your code and then specify what's the timeout for the code to run and how much memory does it need. And that's that. You don't have to worry about the underlying architecture that it's going to use. And to do that, we're using Amazon's web services, two services that they have. One of them is AWS API Gateway, and the other is Lambda. Lambda is a compute resource that's event-driven. As soon as the request comes in, whether it's from an API or from another service hitting it, it will start executing in a container. and it will run extremely efficiently. And it lets us scale horizontally, which means that we can add as many of these as we need without adding any computing power. And then API gateway is the glue that connects the user, the API request, with the actual compute system, which lets us build these API interfaces very quickly and control them. All right, but what does it mean? So let's look at an example. This is a live example from the actual APIs that Cymon is using. So for the API gateway, we just need to specify for Amazon what pieces of data do we want to grab from the request and how does it look like. So we can see it's a post request. We can see the path that you need to specify. And below, we can see the pieces of information we're grabbing from the body of the request, which is the login information, the username and password. And that information gets essentially processed by the API gateway. It extracts this information from the actual post request and moves it to the Lambda system. Lambda, and this is the actual code from our production Cymon API service. So Cymon gets the username and password, runs it through the verification function. If everything is okay, it will create the JSON web token on line 10, and on line 11, it will return back a 200 success response with a JSON object containing your session token. And from that point on, you can hit any other API with the web token, with the JSON web token, and get all the restricted resources. And that's it, really. So I don't have to worry about now servers, where it's running, recovery, and the networking. I just had to specify how I want the gateway to extract the information and what to do with it. So now that we got a little bit of an idea of how serverless systems work, let's examine our pipeline. So on the left side, we have a user such as yourself, someone who might be submitting indicators of compromise, IOCs, to your own feed. So you'd have to send it through the API. We also have above the user automated serverless workers that execute on a cron basis. They have a scheduler that tells them to start extracting or scraping data from different sources and push it through the API to our pipeline. As soon as that comes in, our API worker writes the events into a message bus. On Amazon, it's called Kinesis, but it's essentially a derivative of Kafka. It's a very similar system. What it does is basically it takes messages in the order they came in and outputs them in the same order. But think of it as a pub subsystem. It's a publisher and subscriber system. The publisher is on the left, the subscriber is on the right, which is a small Lambda function that takes the event from Kinesis, takes the events, and writes them to our data lake on S3. So all the events get written to S3 for different reasons. The first one is for storage and analysis in the future. That's why it's called a data lake. So if we need to run analysis, or if you need to export your data, or you want to convert your feed into a specific format, which I'll touch on later, we'll be able to do that by just extracting the data from S3, running it through our Spark cluster, and serving it back to you. But right now, I'm not showing that on this graph because I just wanted to show you the pipeline. So subscribing to the S3 event. So as soon as a file was written to S3 with our event, it will emit a signal saying that a new file was created, and that will get picked up by that small Lambda icon to the right of it. That small icon, the Lambda function will take the event, read the data, and then pass it on to different systems. The top most is enrichment. So it will basically send it to a queuing protocol for running through different query APIs. For example, VirusTotal. So as soon as you submit a reportable on an AP, if it was not reported by VirusTotal, we will double check if VirusTotal has any mention for it, for signatures or domain or anything else. That's just one example. Then we'll also collect different statistics. We'll flip different counters on DynamoDB, which is a system very similar to Cassandra, where we basically collect a lot of heuristics and statistical information about, for example, how many times a specific tag was used, or how many times was a specific AP reported today in the last hour. All this information lives in DynamoDB. And then lastly is our Elasticsearch cluster, which stores all the raw data. So the actual events go into Elasticsearch, which powers, of course, our search in the web application. So when you hit the search API or through the web interface, that's what powers it, which gives us great flexibility into with the schema. Because it's a NoSQL database, we can easily add more attributes to support in the future if we needed to. For example, if we wanted to support mutexes or registry keys as indicators, we can definitely do that. So stepping back, this is the big overview picture of how the entire architecture looks like, with the processing pipeline and the web architecture as well, all fitting together into the same AWS virtual private cloud within Amazon. So as a user, the first thing you're going to hit when you go to our website is our Docker containers running React, running served by Express. From that point on, as soon as the initial request is served, the application runs on your browser because it's a client-side application. It's a React-based application. And then React just interacts with our API, pulling the data, authenticating, and the API in turn pulls the relevant pieces of information needed from either Elasticsearch or DynamoDB. And of course, the pipeline and everything that's happening in between that is kind of obscured in this slide. So let's touch on the benefits of cloud architecture and why did we even go there. So of course, the ability to scale up very quickly. If I need to process more requests, I can either scale horizontally, which means adding more servers to help me process the requests coming in from the load balancers, or vertically, which means adding more CPU and memory to existing servers on Amazon. Both are easily available to us. But that also lets us very quickly, within minutes, to be able to scale from thousands of users to millions of users hitting our API. And as I mentioned, if one region goes down or any natural disaster, we can very easily, without any human intervention, fix it and self-heal the system. Most of it is handled by AWS. All you have to do is just architect your application right. For development and QA, it's really neat because all you have to do is press one button and you can replicate your entire cloud architecture to another account or to an existing account, and then do your testing, release new features on it, anything you like. And the piece that I like the most, I don't want to maintain the servers. I want to prototype quickly concepts and verify they work. I don't want to maintain and build servers and patch them and back them up. So Amazon gives me this great ability to automatically back up databases and build servers on the fly very quickly. But I think arguably the most the biggest benefit in the cloud is the better security ability that you can achieve there. Because the cloud logs every piece of action, every API call, every change that you make, every login. I would argue that there is way more information to make security-based decisions in auditing on the cloud than can on regular hosted at your own office type of deployment, or use a colo hosting company. Right, and lastly, of course, cost savings. You can only run the machines that you need to serve the current demand, and when that demand goes up, add additional machines. Okay, so now let's examine some of the different data types coming into Cymon. So IOCs that we mentioned come from various sources on the internet. Sometimes, some of them will be extremely old websites that were established in the early 2000s to help combat spam and phishing, which was an early phenomenon. But those websites didn't update, but they're still useful. Sometimes we have to scrape them. Other times we use APIs. Sometimes we actually have to download files from FTP servers and then parse them. Some systems also use DNS as a query mechanism for asking questions about whether an IP or a domain is malicious. So Cymon supports all of these and even more to collect and build its reputation database. But something you probably don't know about is our pastebin collection. So we're saving almost every document that goes on pastebin. So those of you who don't know, pastebin is a website, pastebin.com, that started as a very useful tool for people to share text files in between without having to do file transfers. You just copy and paste it and share the URL. But bad guys are also using it, and I would say about 99% of the times, every time there was a breach of a database, a company got hacked, like LinkedIn or Yahoo or anything else, and customer emails and passwords were leaked, then it was always posted on pastebin. They also go down pretty quickly because people report on it, but usually we'll collect it within the first few seconds, which means that we'll get this data. So now that we have this data, we can start scouring it for known patterns in different terms. The terms we use are, for example, our customer domain names and company names. And if we see a match, it usually means that either someone is targeting that company, there is a campaign against them, or something got compromised and information was leaked on them or from them. And usually you'd want to be the first to know about it instead of your customer telling you that they found this info online about you. Doxing, the last line there, means it's the act of researching and publicizing sensitive information on individuals, such as politicians and company CEOs. And the sensitive information usually contains tax returns, mortgages, anything that you would not want to be posted online, health reports, stuff like that. So anything like that, you'd probably want to be able to find very quickly. And we provide an interface for that as well. So just to give you an idea of the amount of data being collected, on average, this is a graph from 2015, but it's still the same. So each bar is about 3 hours. And you can see that we're ingesting between 1,500 to 3,000 documents every 3 hours from pastebin. But let's look at some of the neat things we can do with the data. And one of them is a Twitter robot. So Cymon Bots is a piece of code. By the way, it's open source, and you can find it on our GitHub page. The link is down here below. But Cymon bot is a Twitter robot that will take IP addresses, will listen for IP addresses, and will reply back to you with how many threats it found. So just a neat little concept. But I think the most interesting aspect for most of you guys is our open API. So you can integrate this into your business process or build tools to help you automate data extraction and verification. And of course, integrate with different services. So some of the things that we want to introduce, I'll cover very soon. But here's an example for a leaked credential alert that we sent to a customer of ours. And here we can see a list of email addresses and passwords that was posted on Pastebin a long time ago. So this is the type of information we see all the time and alert our customers, and we highly recommend anyone to use as well. The second example is something that I jokingly like to call passive pen testing. Pen testing is the act of doing a security assessment on a website or a network, emulating what the hackers would do. The point is to identify the same vulnerabilities the bad guys would use and fix them. And SQL injections are a specific type of vulnerabilities that affect websites. This specific post here that you see in front of you is a list of websites that someone identified vulnerable to SQL injections and posted it. Now, one of our customer domains was on that list, and that's why I say jokingly, because we identified the vulnerability for them for something that we didn't necessarily do any work for. We usually charge consulting fees to do penetration testing, pen testing. And we were able to just tell them they have a vulnerability on the website without actively patching the site. But the same would be just as valid for any of you if you decide to run these checks daily. I don't think we have that much time. So yeah, some of the other things we can do are very neat visualizations. You can see daily where and how many reports are coming in about different problems in our visualizations. But let's go into the more useful aspects of what can you use Cymon for and the different tools that were already written by different people. So just as a quick list of some existing tools that you can use, some of them integrate with Splunk to help you correlate logs on Splunk with Cymon. The bottom one is a command line interface for Cymon. The first two are various tools to either help you analyze or aggregate data from Cymon and other tools. But for system administrators, for example, you could create a dynamic block list to run on your firewall or other perimeter devices and alert or block known bad IP addresses, right? And on its own, something like that would help reduce the number of alerts you're getting, right? But for those of you that are a bit more curious and you run a web server, I posted an example script that can take an Apache log and analyze the sources of the different people who are hitting your web server to see if they're a known malicious source of bad traffic, whether scanning or brute forcing and so on. So not entirely useful for production, but for those of you who want to experiment, it's one neat way. But if you take this into a SIEM, if your SIEM takes your web server logs, then you can use that to correlate. It's essentially a simplified version of SIEM correlation. Mozilla has an open source tool called Maas, which is an open source SIEM that uses Elasticsearch, and they have a plugin that correlates data with Cymon as an example that you can, it's something that you can explore and play with on your own if you wanted to. But Before we finish, I'd like to just cover some of the new things that are coming on Cymon in the next few months. So hopefully by the end of Q2, most of these will be released. So I mentioned private and public feeds. So you can definitely create a feed that only you and your employees have access to, or it can be completely public and anyone can benefit from it. But if you set it as private, you can definitely set who has read and write access to it or who can manage it. So you can share it with business partners. For example, if you're in the same sector of a specific industry, and all of you want to protect yourselves if you're in the power and utility sector, and you will just want to create a feed only specifically for attackers and techniques that are coming from, that are targeting this industry, you can easily do that and start collaborating. Or if you're a company like Elasticsearch or a bank, you can create one feed and have all your analysts contributing to the same feed or multiple feeds. We'll also have the ability to do a bulk export of your entire data if you wanted to load it into a different system. Or one use case is Carbon Black, which is a endpoint detection and response tool that detects malware execution and will help you stop it. So you can definitely integrate that with Cymon and have all these signatures for hashes, IPs, domains coming in and helping you detect these threats as soon as possible. Zapier, for those of you who know Zapier, it's a really neat tool to help you as a person automate your life. So that's something that we want to do soon. So you'll be able to trigger on, for example, once your email has been was found on Pastebin, for example, it will send a signal to Zapier, and Zapier will basically run whatever you told it to do, either send an email or hit a web link, a webhook, or process it further. The options are limitless with Zapier, and it's perfect for anyone who doesn't want to touch code. And that's something I'm really excited about, to help expand Cymon and bring it to more hands. And as I mentioned, we'll be able to expand the different types of signatures we're supporting, the different indicators, because it's a schemaless database. So with that, yeah, okay, last point is, yeah, of course, better searching, because we're using Elasticsearch and the ability to jump between data points, starting with looking for an IP, then finding domains associated with it, and then going to hashes, and then back to IPs. You can really keep moving between different pieces of data to finish your research or exploration into the threat. And that's that. I really hope that that gave you a brief overview into how to architect big data systems and how Cymon was built, and hopefully how you can use Cymon as well. If I didn't mention, it's a free tool. As long as I'll be with this entire, I'm going to keep it free. We might add some additional features that will become premium, but hopefully that will just incentivize you to become a customer. So with that, thank you for your time, and I'll pass it back to the ODX team.
Thanks, Roy. There's just a few questions that came in that I wanted to wait until you're finished with your presentation. The first one is, Brian asked, are you able to do identification? Example, you've detected a threat. Are you able to determine who was responsible? Is there enough identification and evidence to enable prosecution of the person or persons responsible?
It's a very interesting question, Brian. And the reason I say interesting is because the biggest problem with the internet and cyber attacks is the I forgot the word for it, the attribution issue. And what I mean by that is that you can never be 100% sure that even if you have all the signals and a lot of them saying that these two computers sent the attack, you can never be sure if that computer sent the attack because it was a willing participant or because it was an unwilling participant. In short, did someone, like, for example, China, I don't want to pick on China, but did they attack that system and then started, if it's a system in Indonesia and we don't have good relations with them, and they knew that and used that as the gateway computer to attack our government agencies. So that's really the issue. Because the Indonesian government will never tell us if it was them, because they'll be too embarrassed. And that's the reason behind it. So in order to tell if it who the person or individual, that's really difficult. It's easier to identify a group that's behind an attack. To actually do attribution to people, you need what's called human intelligence, on-the-ground field operatives that are associating these with the people by observing them. And that's something that, unfortunately, any cybersecurity company will not do, mostly because there's no money in it. The only bodies that will actually go that far are nation states and probably energy companies like Exxon and others, because believe it or not, these kind of companies have as sophisticated intelligence units, as almost as sophisticated as the US governments, because they need to know about different states, especially the unstable ones that have a lot of oil, right? So they might be able to correlate it to a person, but unfortunately we cannot.
Okay, and there's another question here that I think you did already answer, but maybe you can go over it again. It says, how do you identify spoofed IPs?
So the problem is with UDP, you can definitely spoof IP addresses. In TCP, you cannot. And I say that with a caution. You can only if you don't want a response back. On TCP, UDP, because it's stateless, because UDP is stateless, so you can definitely spoof and your source IP, but in TCP it just won't work, or you won't get the traffic back and you will never know if it worked. So that's a problem, because you need to do a full SYN handshake, right? SYN-ACK handshake. So to do that, you need to transfer packets back and forth. And if your source IP is different, then those synchronization packets will not come back to you.
Okay, and the last question here is from Josh. It's what level of curation of data is offered through Cymon? For instance, IPs are often utilized for short durations, and lots of IPs of compromised hosts are dynamic. Additionally, for the information you scrape from Pastebin, do you scrape from other sources that may be paywalled? And you put in brackets, leaked source, have I been pwned, and leak base?
So there are a few questions in this paragraph. Let's work our way backwards. So have I been pwned, leak base, and all of these? I can't tell for sure, but 100% they're using Pastebin as the primary source. And then manually adding more data as they find it on BitTorrents and so on. But all of it comes to Pastebin on it anyways. The only advantage they have is that they store only the leaked credentials, and I store everything that has on Pastebin. But that gives me also other advantages, as in when I want to just search for a company, I can see if there's campaigns that not necessarily someone released leaked credential, but maybe someone is discussing on how to attack or rallying a bunch of people to attack a specific organization by posting information on it. So that's why I prefer my way of doing it when it comes to scraping Pastebin. And in regards to your question about the curation of data, and how to use IP addresses, you're absolutely right. Using IP addresses to block traffic is the shotgun approach, because usually multiple websites will be hidden behind an IP address, usually because of load balancers of hosting companies, where if you use a domain, that would be the more surgical filter mechanism to stop traffic. But in both cases, absolutely, you'll probably want to limit the amount of time you keep those indicators in your blacklist. Absolutely.
Okay, great. Thanks, Roy. I'm just going to finish up with a few final notes for those that are still here. I'm just going to mute your mic, Roy, just in case there's any feedback on your end.
Great, I can cough now.
Okay, and I'm going to see if I can pull up my PowerPoint for you. Maybe. Okay. So if you have any further questions about open data or cybersecurity for ODX or for Roy, you can reach out to us, or Roy has his contact information there on the screen just before now. You can reach out to either of us and we'll make sure that your questions get answered. I don't think my PowerPoint is showing up right now, so I'm just gonna wing it. I know you have to get back to work, but I just wanted to let you know that I sent out an email with a link to the survey with a few questions we'd like you to answer about how the webinar was, what you liked and what you didn't like, so that we can make the next one even better. And as soon as we get your feedback, we'll email you the archive for this webinar so you can rewatch it or do whatever you please with it. I also wanted to briefly mention that we are subscribers to a newsletter called the Open Government Digest, and we're like huge fans of it. It is a twice monthly newsletter that just has a lot of resources that are happening in the space right now, and it's a great way to stay on top of what's going on and let your social media channels know that you're staying on top of the industry. So I'm just going to paste the link here if you wanted to join that. You're welcome to. You can find us on Twitter, LinkedIn. We have a LinkedIn group that we like to discuss open data topics there. We're also going to be joining Facebook soon, so keep your eye out for that, and we hope that you'll join us there. And last but not least, our next webinar is going to be in February. I think the date is the 21st, and it's going to be with Myovision. So we have a link here if you wanted to sign up for that right now. You can do so. But if you're not ready to sign up yet, we'll be sending out emails within the next month to get prepared for it. So we'll definitely be hearing about it some more on our social media and our newsletter if you're subscribed. Yeah, I think that's it. Thank you so much for joining us, and I hope you enjoy the rest of your day. Thanks, Roy.